So now we're back to the Intro to Machine Learning by Kaggle, and we're on to our first machine learning model. So we're going to be building our first model. Hooray! All right. So let's start with this one right here, selecting data from modeling. So our data set had too many variables to wrap our head around, or even to print out nicely. I don't really remember, but yeah. I think they're talking about the exercise? I don't remember. Anyway, whatever. But here we go. How can we pare down this overwhelming amount of data to something we can understand? So pare right here just means to slice off. Let's go with that. Pare. Trim. Cutting along its outer edges. All right, there we go. So yeah, how can we pare down this overwhelming amount of data to something we can understand? So trim it up. We'll start by picking a few variables using our intuition. Later courses will show us statistical techniques to automatically prioritize variables. That sounds pretty cool, actually. To choose variables or columns, we need to see a list of all columns in the data set, right? That is done with the columns property of the DataFrame. So the bottom line of the code below. So we've got the import pandas as PD here. We've got the file name right here, and then we're going to read it with the pd.read, and then we've got melbourne.data.columns, right? So that's going to give us this right here. It's going to be this index, and we're going to have this list with all these column names like address, room, suburb, whatever. And then also we'll have the D type of object right there, right? So, and we got to read this. This is actually important. So the Melbourne data has some missing values. Some houses for which some variables weren't recorded, okay? So yeah, there's missing values in the Melbourne data. We're going to learn to handle missing values in a later tutorial. Our Iowa data doesn't have missing values in columns we use. So we will take the simplest option for now and drop houses from our data. And we're not going to worry about this much for now, but here's the code to drop this stuff. So drop na, we got this drop na right here, and that drops missing values. Think of the na as not available. You got it. All right, so we're saying Melbourne data now equals Melbourne data dot drop na axis equals 0, right? So that's just dropping anything that has the null or not a number going on. I think it's just nan, so whatever. All right, so let's go back to it. So there are many ways to select a subset of our code. The pandas course covers these in more depth, but we're going to focus on 2 approaches for now. We already know the pandas. We're going to use dot notation, which is going to select the prediction target. So like whenever we said on the wine one, we would be like wines.price or reviews.price, whatever it was. And then also selecting with a column list, which we use to select the features. Okay, so actually using a list full of feature names to access. What are we doing? Selecting the column. Select. Okay, so yeah, that's how we select the columns. Okay, cool. Awesome. All right, so selecting the prediction target, we can pull out a variable with, we can pull out a variable with dot notation. Okay, this single column is stored in a series, okay, which is broadly like a data frame, but with only a single column of data. We know about that. We're going to use the dot notation to select the column we want to predict, which is called the prediction target. By convention, the prediction target is called Y. So the code we need to save the house prices, the house prices in the Melbourne data is this here. So Y, because that's what the convention is, equals Melbourne data.price, right? So just like when we had reviews.price or reviews.country, whatever, we're doing Melbourne data.price in this one. And price is capitalized over here. Boom. So yeah, we got to use the capital, I'm pretty sure. All right, let's keep going. So choosing features. The columns that are inputted into our model and later used to make predictions are called features. So the rest of the columns that aren't the target. So this is the target column, and then we've got the features column, basically, or potential features column, we can call them. I don't know, who cares? Let's go. So in our case, those would be the columns used to determine the home price, all right? Sometimes we will use all columns except the target as features, all right? That kind of makes sense. Other times we'd be better off with fewer features, okay? So yeah, like we can look up here, and we probably don't need, I don't know, does that help? Sell it? Seller G? I don't know what that even is. Method? Do we need that one? I don't know. I don't even know what those would be. But let's keep going down here anyway. So, well, for now okay. Other times we'll be better off with fewer features. For now, we're going to build a model with only a few features. Later on, we're going to see how to iterate and compare models built with different features. For now, we'll build a model with only a few features. Gotcha. Okay, so we select multiple features by providing a list of column names inside brackets. Each item in that list should be a string with quotes, right? So we've got the rooms, bathrooms, land size, latitude, and longitude. That will tell us, that will give us a price somehow. Okay. I kind of want to go deeper into the data science, but let's just get through this for now because I want to know, like, how do they actually, weight this stuff? Anyway, whatever. We'll figure it out. Where are we? Here? Yeah. So by convention, this data here is called X, okay? This data is called X. So yeah, no, not this, but the data frame that we're going to make, okay? Using these, what are they? What are those things called again? Features. It says features right there. So using these features, we're going to make this data frame called X. So X equals Melbourne data, Melbourne features, and that's going to make a new data frame for us. So let's quickly review the data we're going to be using to predict house prices using the describe method and the head method, which shows the top few rows, okay? So we've got describe, which has all of our little property. What did we use? What did we call these? There's a name of the lesson, like something. I forgot what these are called, but they have that name. And then we've got the x.head, and we've got the first two, the middleist one, and we got the last two as well, of rooms, bathroom, land size, latitude, and longitude. All right, so we've got this little data frame. Looks like it, at least. Visually checking our data with these commands is an important part of a data scientist's job. I like the sound of that. We'll frequently find surprises in the data set that deserve further inspection. Pardon me. All right, so now we've got building our models. So we're going to use the Scikit-learn library to create our models. When coding, this library is written as sklearn, as we will see in the sample code below. Okay? Sklearn is easily the most popular library for modeling the types of data typically stored in a data frame. Okay. Okay, we'll figure out what that means later. The step to building and using a model, the steps to building and using a model are define. So what type of model will it be? Is it going to be a decision tree, some other type of model? Some other parameters of the model type are specified too. I don't know what this means. Honestly, whatever though. Fit. We're going to capture patterns from provided data. This is the heart of modeling. So we're going to find patterns from the provided data somehow using this scikit-learn, right? Anyway, predict is just what it sounds like. I believe it. Evaluate, we're going to determine how accurate the model's predictions are. Sounds good. So here's an example of it defining a decision tree model with scikit-learn and fitting it with the features and targets available. Features and target available. Okay, cool. There should only be one target, right? Anyway, let's go. So from Scikit-learn.tree, we're going to import the decision tree regressor. I guess this is a model that we're going to fit this stuff into. So we're going to define the model down here. We're going to specify a number for random state to ensure same results on each run. Okay. So we've got Melbourne model equals decision tree regressor random state equals 1. And then we fit the model by saying Melbourne model dot fit. And then we have the big X, which is this data frame right here. And then we've got the little y, which is this what is the thing called? Series with all the prices in it. With the 7 prices at least. Yeah, so there's that. Okay. And then the output's going to be decision tree regressor random state 1. I don't know what that means. But let's keep going. So many machine learning models allow some randomness in model training. Specifying a number for random state ensures we get the same result in each run. This is considered a good practice. We can use any number and model quality won't depend meaningfully on exactly what value we choose, right? So we just had to use the same number every time. You could use 1, you could use 1 million. But I would say the fewer the keystrokes, the better, right? But also you could put like a number like 3 and really make people say, oh, this guy's a wizard. I don't know if that's good though. I don't know if that's a good way to do things. Anyway, let's keep going. So we now have a fitted model that we can use to make predictions. Okay. So yeah, I guess this is the fitted model right here, and we'll access this in a little bit. We'll see. In practice, we'll want to make predictions for new houses coming on the market rather than the houses we already have prices for. True. But we're going to make predictions for the first few rows of the training data to see how the predict function works. Okay. Well, let's look at it then. So we're going to print in a string, make predictions for the following 5 houses. And that's going to print out right here. And then we're going to print x.head. And so we've got the same head from over there. And then now we're going to say print the predictions are, and then we're going to do Melbourne model dot predict. And then we're going to have x.head. .predict. Okay. And then we're going to have x.head. And so here's our predictions right here for the houses. For house 1, house 2, house 4, house 6, and house 7. Okay. And there's that. That's the end of that. I wanted to kind of go into that more, but maybe later. So let's go to the next one. All right. So now we're on to the exercise, our first machine learning model, and we'll see you next time.